Hello friends, welcome back. Hearty welcome to you. Let us see how to find out the integral of root of tan x plus root of cot x. There are so many ways of solving this problem. We'll try to look at one of the easier ways of solving this. And remember, in integration you can have more than one solution. The answer will be the same, but it can be represented in different ways. Okay, now what is our logic to solve this problem? We'll try to convert them into sine and cos. Then we will see what we need to take as substitution t equal to, so that we can get it into one of the standard forms and solve it by applying those formulas. So let's convert what is given to us, that is I. We'll write down I equal to, now what is root of tan x plus root of cot x? Equal to root of sin x by root of cos x plus root of cos x divided by root of sin x dx, which is equal to sin x plus cos x divided by root sin x cos x. Now our logic should be to think what I need to take t so that the numerator will be going away. So that means what function derivative is sin x plus cos x? Now if I take t equal to sin x minus cos x, then differentiate it, we will have dt equal to cos x plus sin x dx. Now you see very clearly that the numerator can be written as dt. So we will write down that is equal to dt divided by root of sin x plus sin x cos x. Now we will multiply with 2 root 2 both numerator and denominator. Why are we doing that? Let's understand. Now we have to write root 2 sin x cos x, which is like 2ab term. We have to write it in terms of our t, which is sin x minus cos x. So I will write it as 1 minus of sin x minus cos x whole square. You can check now. Sin square x plus cos square x is 1, so 1 and 1 will cancel. 2ab term will be minus 2 sin x cos x, but there is one more 1 minus there, so that will give you as root of 2 sin x cos x. That means what we have now can be written as root 2 out. We will have dt divided by square root of 1 square minus t square, and we know the formula for 1 by root of a square minus x square, that is sin inverse x by a. So can I write it as root 2 sin inverse t plus c, or which is equal to root 2 sin inverse t is sin x minus cos x. That is our solution, but this can be also written as root 2 tan inverse of tan x minus 1 divided by root 2 tan x plus c, because in some textbooks you see the solution as this, but even you get this one, these both are equal. Let us see why they both are equal. Let's take the triangle what we have here. Let us say theta here, and let us take this is theta. This whole thing is equal to theta. Then sin theta equal to sin x minus cos x. But sin x minus cos x is also equal to, can we write down, sin x minus cos x is also equal to tan x minus 1 divided by secant x, which is equal to root of 1 plus tan square x. What is that we are trying to do? Convert sin and cos in terms of tan. So now sin theta is here tan x minus 1 divided by root of 1 plus tan square x If you are able to do Pythagoras theorem, you will get the missing side is square root of 2 tan x, which is nothing but equal to, instead of sine inverse of sin x minus cos x, we can write it as now tan inverse of tan x minus 1 by root 2 tan x plus c. So that is one of the easier way how we can solve this problem. We don't need to go for multiple substitutions. One substitution which makes sure that you get your answer in very few steps. So root 2 sin inverse sin x minus cos x plus c and are also equal to root 2 tan inverse of tan x minus 1 by under root 2 tan x plus c. So let's have a recap of this. What we have done, we have to find out the integral of root of tan x plus root of cot x converted into sin and cos. We got sin x plus cos x by root of sin x cos x. Now we'll take sin x minus cos x equal to t, so that sin x plus cos x dx will become dt, and we multiplied with it root 2 numerator and denominator, so that whatever we have in the denominator looks like 2ab term, which can be written as root of 2 sin x equal to 1 minus of sin x minus cos x whole square. But we know sin x minus cos x is t, so we can write it as root of 1 square minus t square, for which the formula is sin inverse t. Now once we know that t equal to sin x minus cos x, we can substitute it back. Our solution will be root 2 sin inverse sin x minus cos x plus c, but that is also equal to root 2 tan inverse tan x minus 1 by under root 2 tan x plus c. Why? Because sin x minus cos x by 1 divided with cos x will become tan x minus 1 by secant x, but secant x is root of 1 plus tan square x. Now take a triangle and put sin theta equal to tan x minus 1 by square root of 1 plus tan square x. Then you get the missing side is root of 2 tan x. That means sin inverse of sin x minus cos x is also equal to tan inverse of tan x minus 1 divided by under root 2 tan x.